Algebra 1, Chapter 1, Section 8, Interpreting Graphs and Functions. Now, we've talked about this a little bit. If you remember 2 sections ago, I believe it was, when Francesca was riding her bike, we were talking about what the graph means the whole time. But that was just kind of like a very basic kind of figuring out like, oh, she's getting further away, or, money's increasing or something like that, whatever the problem was. What we're focusing in more on this one is looking at particularly important aspects of the graph and what they can mean. So that's what we're talking about here, is the key features of the graph. Intercepts are where it crosses one of the axes. Those are very important. And we have more, but we're going to talk about intercepts right now. The x-intercept is where it crosses the x-axis. The y-intercept is where it crosses the y-axis. So you can see I highlighted them there on the problem just to get started on it. So, but that's the whole idea, is if you can see where it's crossing the axes, which is, axes is the plural of axis. So this is the plural, right? It's not axes, it's axes, math. But now let's interpret these intercepts. So what does this graph show here? Something about physics, all right? So that usually gives us some broader context. Now let's get the context down. The graph shows the height y of an object as a function of time. So it's, if you think about it here, it's the height as a function of time. Identify the function as linear or nonlinear, then estimate and interpret the intercepts. So if you remember the last, I think it was the last example in the last set of videos. I should know, it was like 30 seconds ago for me. The big difference between linear and nonlinear: straight line is linear, any sort of curving is nonlinear. So, does this graph curve at all? Yes, it curves. So we're going to classify it as nonlinear. So this graph is non-linear. All right. Now, we're going to then estimate and interpret the intercepts. And I covered them up here, so let me erase them real quick, and I'll use some smaller dots on them there. So pink is the y-intercept. It looks like it's between 15 and 20. And the yellow one here is the x-intercept. That looks like it's after 7. So let's be systematic about how we write this here. The x-intercept, it's always nice to do the x-intercept first because that's the inputs. That's the yellow dot that I've drawn on the graph there. If you can see it, it's kind of smaller now. But looks like it's just beyond 7. So it looks like it's like 7.2 seconds. All right. Well, what does it mean? Like, what does it say is a function of time, height of a launch object. So this here right here is going to give us some clue. It's like a rocket going up. Well, what happens when it goes back down and hits when the height is 0? Well, when height is 0, that's the ground, right? So 7.2 seconds, it represents when the object lands, because it came back to the ground. Y-intercept. So I'm looking at the pink here, and it's just this little bit on the side of the graph there. It looks like it's between 15 and 20. Let's just call it 17. And that's in meters. and it's at time 0. So if this is the height of a launch object, has an object been launched at 0 time? Think about the countdown of like the space shuttle or something. Though I don't know if you remember the space shuttle because that was so long ago. About of a Tesla rocket, right? The Falcon rocket, I think it's called. So you got the countdown: 5, 4, 3, 2, 1, 0. Commence launch, and then it starts taking off. So when it's at 0 time, it hasn't taken off yet. So this would be 17 meters is the height at launch time. So that's what we're trying to do. Interpreting them is very difficult. If all you can do is get to recognize what those intercepts are, start with that, then ask me for help about interpreting it, and I can help you out there.